the cold, indifferent silence of the cosmos, we have always been the observers. For millennia, we stared at the flickering lights of the night sky, wondering if any of those distant diamonds held a reflection of our own existence. We built towers to reach them, then telescopes to see them, and finally, machines to visit them. But for all our striving, the universe remained a graveyard of beautiful, sterile rocks. Until now, deep in the darkness, 120 light-years away, a silent revolution has been captured in a beam of infrared light. The James Webb Space Telescope has turned its golden eye toward a world that shouldn't be possible. A world that defies our understanding of chemistry and biology. This is not just another planet. It is a signal, a whisper across the void that suggests we are no longer alone. We are standing on the precipice of the greatest discovery in human history. A discovery that doesn't just change our science, but changes what it means to be human. But what if the signal we found isn't a sign of life as we know it, but a sign of something much more terrifying? To understand what Webb saw, we have to look at K2-18b. It is a world twice the size of Earth, orbiting a cool red dwarf star. For years, it was a mystery, a sub-Neptune planet, a category of world that doesn't even exist in our own solar system. We didn't know if it was a gas giant or a rocky wasteland. Then, Webb peeled back the curtain. It found methane. It found carbon dioxide. And then, it found something that sent shivers through the scientific community. Dimethyl sulfide. On Earth, there is only one way to produce this molecule. It is not made by volcanoes. It is not made by lightning or minerals. It is produced exclusively by life, specifically by microscopic marine life in our oceans. By finding this molecule, Webb has effectively detected the smell of an alien sea. We are looking at a Hycean World, a planet covered entirely by a global ocean, tucked beneath a thick envelope of hydrogen. It is a vast, dark aquarium floating in the abyss. Yet, the discovery of a biological signature brings with it a haunting contradiction. If life is there, why does the planet look so hostile? K2-18b is bathed in intense radiation from its temperamental star. Its atmosphere is a crushing weight of hydrogen that would flatten a human in seconds. Beneath that beautiful shimmering blue surface, the pressures are so immense that the water might not even be liquid or gas, but a strange exotic state called supercritical fluid. It is a place of extreme beauty and extreme violence. And yet, the data persists. The 99.7% certainty doesn't come from a single glimpse, but from the relentless repetition of the light spectra. Every time the planet passes in front of its sun, the light filters through the atmosphere, leaving behind a fingerprint. That fingerprint says life. It forces us to ask a staggering question. Is life a fragile miracle? Or is it a cosmic infection that can take hold in even the most hellish environments? If a crushed, irradiated water world can host a biological engine, then the universe isn't just sparsely populated. It is teeming. If the universe is indeed teeming with life, then we must face the darkest implication of the James Webb discovery, the silence that preceded it. For decades, we listened for radio signals and looked for megastructures, finding nothing. We assumed life was rare. But if Webb is finding biological signatures on the very first Goldilocks planets it examines, it means the great silence isn't because life is rare. It's because we've been looking for the wrong thing. We were looking for civilizations, for technology, for people like us. But the universe might be a vast, silent ocean of biology that never leaves its home. K2-18b could be a planet of trillion cell organisms, massive leviathans swimming in a dark, global sea, completely unaware of the stars above them. They have no fire because there is no oxygen to burn. They have no radio because there is no dry land to build on. They are alive, they are conscious, and they are forever trapped. We are looking at a cosmic zoo where the gates are made of physics and the bars are made of gravity. This realization shifts our entire perspective on our place in the timeline of the universe. We often think of ourselves as the protagonists of the cosmic story, the masters of intelligence. But the discovery of life on a Hycean world suggests we might be the outliers. We are the strange ones, living on a dry, rocky outcrop, using fire and metal. Most life in the universe may be aquatic, tucked away in the warm, dark bellies of moons like Europa, or planets like K2-18b. We are the lonely mountain dwellers looking down at a universe-sized ocean. And as we stare into the data from Webb, we realize that the 99.7% probability isn't just a number. It is a mirror. It tells us that the chemistry of the cosmos is biased toward existence. The carbon, the hydrogen, and the light are all conspiring to create something that breathes. We are not a fluke of nature. We are an inevitability. But as we reach out to touch this new world, we must wonder if we are ready for what happens when the observer is finally observed. The James Webb Telescope is more than a tool. It is a time machine and a bridge. By catching these few photons of light, we have bridged a gap of nearly 700 trillion miles. We are sitting in our small rooms on our small planet, reading the chemical diary of a world we will never touch. There is a profound loneliness in this discovery. To know with almost total certainty that something is alive out there, and to know simultaneously that we can never speak to it. We are like children looking through a frosted window at a party we weren't invited to. But perhaps the invitation is the discovery itself. Perhaps the point of the universe providing these clues is to see if any species is brave enough to keep looking, to keep dreaming, even when the distances seem impossible. We have found the ocean. We have smelled the salt of an alien sea. The mystery of the only is over. The mystery of the many has just begun. We used to look at the stars and feel small because of the vast emptiness between them. We felt like dust in a cathedral of nothingness. But now, as we analyze the light from K2-18b, the emptiness is starting to feel crowded. The dark spaces are filling up with possibilities. We're looking at a universe that is heavy with the weight of billions of heartbeats, billions of cells, and billions of untold stories. The 99.7% chance of life is a doorway. We have spent our entire history standing in the hallway, afraid of what lies on the other side. Now, the door is swinging open, and as we peer into the room, we see not a void, but a reflection. We see the same struggle for existence, the same dance of atoms, the same spark that started in our own ancient seas. We are not the authors of the story of life. We are simply one chapter in a book that is longer and older than we ever dared to imagine. As the James Webb Space Telescope continues its silent vigil, turning its gaze to the next star, the next shadow, and the next signature, we are left with a final, haunting thought. If life is this common, if the universe is this eager to breathe, then where does that leave us? We are no longer the center of the universe, and we are no longer the only witnesses to its majesty. We are part of a cosmic community that is mostly hidden from view, whispering in the dark. The high probability of life on K2-18b is the first sentence of a new era. It is an era where we must learn to be good neighbors to the silent worlds. It is an era where the alien is no longer a monster from a movie, but a microscopic organism in a distant sea, doing exactly what we did 3 billion years ago. We are watching our own past through a telescope, and in doing so, we're catching a glimpse of a future where the Earth is just one island in an infinite archipelago of life. The data is clear. The light has spoken. The universe is alive. And now, we are left with the most difficult task of all, living with the knowledge that we are not alone, but we are still, for now, out of reach. We have found the signal in the noise. We have found the heartbeat in the vacuum. We have found the 99.7%. But as we close our eyes tonight, looking up at that same red dwarf star in the constellation of Leo, we have to ask ourselves one last thing. If we have finally found them, how long have they been waiting for us to notice?